So I know you've learned this in pre-calculus. This is how to break up fractions. So we're going to be going from this direction to this direction. But let me just kind of talk to you about how it does work. So these two fractions, if I make common denominators, which you know how to do, would be x minus 1 times x plus 2, which does turn out to be this. If I multiply top and bottom of this one by x plus 2, and if I multiply the top and bottom by this one by x minus 1, it does turn out to be this. So what we're going to get is something like this in our integral, right? Like here. And we're going to want to break it up into these two fractions because I can do the integral of these two things, right? Here I would let u equal x minus 1, du would be dx. Here I would let u equal x plus 2, du would be dx. So I would get just enter 2 over u, du minus 1 over u, du, right? And this would be this u here. So this would give me 2 ln of x minus 1 minus ln of x plus 2. So I'm getting you the reason why I want to do this. I want to take this polynomial, this polynomial over this polynomial, this fraction, break it up into these two so that I can do these simple integrals. Okay, so this is a method that works, and so these are the criteria to make the method work. So the first deal is that the degree of the numerator must be smaller than the degree of the denominator. If not, then you need to do long division. So here, this is a cubed over x to the 1 power. So long division is necessary. So I kind of went over that before, but let's just go do it again. So here I have x cubed plus x. That would go in the box, and x minus 1 is the divisor. So I'd say, okay, x squared is what I need to multiply by x to get x cubed. X squared times negative 1 gives me a minus x squared, and then I would subtract. So the x cubes would cancel, it would go away. So I would get a positive x squared. Sorry, did I say that wrong? Yeah, I said x cubed, okay. And the positive x squared carries along, and then a positive x. So I do it again, and I say, okay, positive x times this x gives me x squared minus x, and then I would subtract. So those x squareds would be gone, and from x and then plus x, I'd get a 2x. So I'd have a plus a 2 here, multiply here, 2x minus 2, subtract. So the 2x's would go away, and I'd be left with a remainder of a positive 2. So that's where this comes from. X squared plus x plus 2 comes from here. And then this 2 is this to the remainder over the divisor, which is this. So what this means is that this turns into this inside the integral. And then you can just take each term and integrate it, and this being an easy u substitution. Okay, so this one didn't need our partial fraction decomposition, but sometimes that's going to happen where you have a higher degree of a polynomial in the numerator over the denominator. So these always have to be just done on polynomials, no trig functions, no radicals. Okay, so what they need to look like is ax plus b, linear factors, so that means x is to the highest power of 1, or quadratic factors, where the x is to the highest power of 2. Okay, so let's look at how we break this up. So this is a method that works. So when I've got different or distinct linear factors in the denominator, so I'm always looking in the denominator of the fraction that I have. So this is an x to the 1 power. This is a 2x to the 1 power minus 1, and this is an x to the 1 power plus 2. So these are different linear factors. So I put the letter a over the x, I put the letter b over this 2x minus 1, and I put the letter c over this x plus 2. So this is the first step, and I'll talk in the next pages to come of how to solve for these a, b's, and c's, but this is how you break it up if they're different linear factors, so x to the 1 powers. Okay, so let's say they're linear factors that are repeated. Like this is x being repeated twice. So you take a over the x and b over the x squared. So it's like you're building to that x squared power. Here I have x minus 1 cubed. So I say c over x minus 1, d over x minus 1 squared, and e over x minus 1 cubed. So you build up to that outside power. All right, so these are linear factors for both of them. So notice the letters that go on the top, they just are simple letters, right? There's no x's on the top. So when I'm talking about quadratic factors like this, so irreducible means cannot be factored anymore. X squared plus 4, you know, cannot be factored anymore. So this is an irreducible quadratic factor. So this x squared plus 4 gets a bx plus a c on the top. This x here is just a linear factor, so I'm just tossing it in there so you can see the difference. It's a over x. So this fraction breaks up into these two terms. So what happens if I have an irreducible quadratic squared? Then I have to build up to that outside power. So I'd put the a over the x, just putting it in there so you can see the difference between them. This x squared plus 1 to the 1 power gets a bx plus a c on the top. And then x squared plus 1 to the squared power gets a dx plus an e. So this is just how it works, and I know I've given you quite a few homework problems that you just get to break it up to make sure you have the first step right, because if you don't have the first step right, then you can't go any further.